Now, one other a key idea we want to talk about, I want to talk about now, is the idea of overriding functions. And this will actually become more important as we go. It may just seem like kind of a neat quirk at first, but overriding functions is an important principle to help us support polymorphism. So inheritance is one of the key ideas of object-oriented programming, and polymorphism ties in with it. And is also really important. So we've seen the basics of inheritance, and now we're going to add in a feature that gives inheritance a little more strength, okay? Overriding functions. Okay, so what happens when a base class and a derived class have a function of the same name? So let's say in my base class, I have a function f, and then in my derived class, I have a function f. What happens here? Especially what happens, am I allowed to do this for one? Is this okay? Because it seems to violate the single name rule. Right, these two functions have the same name. This function gets imported into the derived class, which means in my derived class, it's like I have two functions with the same name, and they have the same argument list. They're empty. That seems like a problem. So is it even allowed? And the answer is yes, it's allowed. And this is called an override. So this function in the derived class actually overrides the function in the base class. It takes the place of the function in the base class. And so if we try to call function f on a derived object, we'll only see the f inside the derived class. We'll not see this f from the base class, right? It takes precedence. The function in derived takes precedence over the function in base. And then whenever this sort of thing happens, we call it an overridden function, right? We'll say that derived, that f in derived overrides the f in base. Or simply, we might say base f is overridden by another function in the derived class. So we can do this. And then the question is, what's happening? Like which one gets called? How's it working? Well, if we just add some print statements in here so that we can kind of see what's happening, what the compiler is choosing to do, then inside main, I can instantiate my derived class D and then call d.f. And what's going to happen here is the compiler knows that the derived class is overriding function f. And so it's going to call the function f in the derived class, and it's going to print derived to the terminal when we run this code. The overriding function executes. Now, what if the function argument lists are actually different? So what if in my base class, f takes an integer argument, and in my derived class, it takes no argument. And then down here in main, I try to call f with an integer. In other words, I try to get around, what I'm interested in is because of the fact that these argument lists are different, is it kind of like function overloading and they're different functions, and this f doesn't override the f with an argument. Well, it turns out that overriding is very strong, and it only cares about the name of the function. And so the fact that I placed a function called f in my derived class, it basically blocks every function named f in the base class. And so the compiler can no longer see this function from the base class, and it will call this a syntax error because I'm passing in an argument to a function that expects no arguments. This kind of defies maybe our gut feeling about function overloading in C++ and how it should work. But nonetheless, overriding was designed to be very strict. And it's purely based on the name of the function. It ignores the arguments to the functions. So just the mere presence of a function named f in the derived class blocks all the functions in the base class by the same name. And since they share a name, we can't call that function directly anymore. So that's both a good thing and a bad thing, because it's a good thing because if you're implementing a class with inheritance and you provide an override, then it's kind of letting you know you might have messed up, right? And you didn't quite match the signature of that overridden function. So it's kind of like a helpful warning message from the compiler that you did something wrong. Okay, but the good news is we haven't totally lost access to that function. We can still use it. It's just we have to tell the compiler we want to use it. We have to make that explicit. So we've talked about the using directive in the context of namespaces, but you can also use this using directive in the case of inheritance. And we can tell the compiler that inside our derived object, we will be using the function f in base. And so it's this kind of weird syntax here where we say using base f. And since we put it in the public part of the class, we're saying that we're going to use f and we're going to use it in a public way. It's going to be available for public access. And now the compiler is able to see the version of f that takes an integer and the version of f in the derived that doesn't. Okay, and so when I call this function f that takes an argument now, normal function overloading kicks in, and the compiler is able to see both the f from the base and the f in derived, and it's able to pick the correct one. It will actually print base this time in this code. So by putting in this using directive, we're able to basically move the function from base into derived and stop the overriding from blocking it. It's kind of a subtle thing. We're not going to use this a lot. The idea of overriding is more important than this idea of bringing the function in from base with this using directive. Okay, but I just wanted you to know that it's possible. C++ lets you do a lot of things, and the most important concept here is the overriding concept. And kind of the secondary idea is that we can overcome it if we really want to. Okay, so why would overriding be helpful? Well, classes that are similar and do similar things should have similar interfaces, like functions with the same name. And but a derived class may want to change that functionality to work differently in some way without changing the interface. Well, let me show you a little example of that. Let's say both the base and derived class have a function print. And when I print the base class, I should print something that makes sense for the base class. And when I print in the derived class, I should print something that makes sense for the derived class. I don't want my derived class print to be identical to my base class print. That's probably not helpful or useful. And so these two functions are the same, right? But they work differently. And what I really want to have happen, I need the compiler to help me manage this, because in my derived class, there could be the appearance of a conflict, right? That there are actually two prints. Now, which one do you pick? Well, the default rule is that the print function in the derived class overrides the print function in the base class. So this is the way we think about it by default, that if I derive from a base class and I provide a new implementation for a function that matches a name in the base class, I'm overriding it, I'm changing it, I'm making it work in a new way just for my derived class. Okay, so in summary, the primary goal of inheritance is reusing functionality, but inevitably sometimes we want to customize functionality in a derived class. This is the beginning of the nugget of polymorphism, that classes may be similar in a lot of ways, and they may share a lot of functionality, but sometimes we need to change them to be a little bit different. Okay, overriding functions is one way we do that. Like if we want to print out a bunch of different objects that are all kind of shared inheritance relationships with each other, we still want them all to print a little bit differently, very likely. When it comes to overriding functions, all that matters is the name of the function. If the name is shared, then the function in the derived class overrides the function in the base class. It doesn't matter how many arguments or what the return types are. As long as the name is the same, overriding kicks in. And overriding, as programmers, it lets us, it gives us kind of a simplicity of thought. we know that if we want to change the behavior in a derived class, we just need to override a relevant function and we can change its behavior.